Welcome to part 3 of preparing to study A-level computer science at the Campion School. This video is on data types and constants. Hopefully you're now becoming a bit more proficient at using VB.net, even though we're doing only basic things, so we don't need to look at the very sort of simple things as much anymore, and we can just move on and the videos can become a little bit less waffly. But well done for staying with me up until this point. In this video we're going to discuss a range of data types which are available to you, and you should be able to choose from a little bit more than just integers and strings now. And then we're also going to look at constants, which are similar to variables really, except they don't change, as you can imagine. So before we move into Visual Studio, I'm just going to have a look at the different data types which are going to be available to you. If you can't remember all of these for now, not to worry. We've seen integers so far, and I've spoken a little bit about bytes and singles and strings. So if you have a look, integers being whole numbers, I've explained why we want to differentiate between integers and other real numbers, okay, due to memory restrictions. But also look, the range is important as well. Now, I've said that we can get int64, we can get larger integers. We can also get signed integers as well, and it affects the range. If you want to go and find out what the values are, you can calculate them yourself once you work out how to do it. But you need to know really a little bit about how negative numbers work in binary. So for now, we'll just always use a signed integer, which is just the data type integer, for now, whenever we're acting with these numbers. Bytes are 8 bits large, but they go in the range of 0 to 255, so they're unsigned. If you want to get a number that's below 0 and that would fit into 8 bits, then you can use an S byte, and they only go up to 127, but then they go down to a number of a similar magnitude. I think it goes down to -128 or something, but they allow you to save a bit of memory. You can save quite a bit of memory as well. If you know that the number's only ever going to be small, use a byte. A single lets you have, as you can see, I've got a standard form number there, a very large number, look at that, but it means that you're going to miss some precision on that large number. So the precision thing is basically, you will look at this in a bit more depth, but it's what allows you to get numbers with fractions in them, numbers with a fractional part. I do want to refrain from calling them decimal numbers, because decimal actually just means it's a number expressed in base 10. What you mean is a number that's got a fractional part, it's got a decimal point that's visible to you in it. Char is a single character. Any one character can only store one at a time, is 16 bits, because of the encoding system that it uses. And then a string is a special data type. For now, we're just going to say it's a group of characters, and we know before we've seen strings inside speech marks, and they come up in that claret text that we've seen before. And then finally, a boolean is a special one as well. It's a true or false value, and you literally set it to true or you set it to false. And the size, do you know what, I don't know off the top of my head, you can go and look it up if you like, but it's fairly irrelevant. I don't know what the size is in VB.net, but they can only store one value or the other. The smallest possible size you could store a boolean in would be just 1 bit, wouldn't it? So we could have 0 for false, 1 for true. When we look at selection statements, we'll look at booleans in a bit more depth. So I've actually written the program out that we're going to look at beforehand, so I'm just going to go and set up a new document in Visual Studio. So go into Visual Studio, create a new project. Remember to use console application VB, and we're going to call this one a VAT calculator. So create the project, and I am going to write the code out by pasting it in, because I've already typed it. So there we go. I've done it twice. There we go. So we've got our program. So our program, once again, I've included comments in. We're going to declare our variables. We've got 3 variables. Notice they're singles. So that means we can use numbers that aren't whole in there, and it means that we can actually produce new values that are not whole numbers, and we can store them. And they're probably going to be as accurate as we need them to be for what we're going to do with this. So single is absolutely fine. We can save a bit of memory rather than using a double, which is the uses twice as much memory. Enter the user's cost, nothing new there. and then just calculate the tax. So what we're going to do is we're going to get the VAT, which is going to be a value, and we're just going to work out what tax basically needs to be paid. So we're going to then just output that value there. So if I run the program, at the moment, cost is input by the user, but I don't have a value for VAT in order to generate the tax. So VAT, we're just going to assign it. So normally, well actually in Britain anyway at least, VAT is 20%. So what I'm going to do is I'm going to do 0.2. Okay? So 0.2. If I then run the VAT calculator, if I enter the cost of goods, say I'm going to buy something for £10, oh, I've got an exception there, look. Ah, look, I've got an error. So this is the first time you're going to see any errors pop up if you've not caused one already. Let's just quickly look at it. It tells you what's wrong. Conversion from string, the VAT is, to type double is not valid. Well, that doesn't mean anything unless you've seen that before. But if you have a look down there, you can see the VAT is times tax. Actually, that should be an ampersand, shouldn't it? That should be an and sign because I'm trying to join tax to that string. And notice I haven't got space after that colon. And that's going to look a bit ugly if I don't put that in there. So I'm going to stick it into it and see what happens. So let's buy my item for £10. The VAT is £2. That's correct. Okay, that's what I want to see. So what I want to do is I want to actually protect VAT. I'm going to turn that into a constant. Okay, now at the moment you can assign a different value to VAT. I could in theory also type in something that lets me assign another value at the user's input to VAT. Well, I don't really want to be able to do that because VAT is VAT. I don't really have any control over VAT. It's a constant value in this program. Okay, I know VAT can change, but it is in terms of our program, it's constant. So what I'm going to do is I'm just going to assign that. I'm going to just say const before it. So const VAT, and if you look, VAT is declared. So if I take VAT out of there and I say const as single, VAT equals 0.2, the program is going to run exactly the same way. The VAT is 2, but if I were to then try and assign something to VAT after that, so let's do 1.2, I've got the red underlined squiggle, but the constant cannot be the target of an assignment. Once a constant's been set, it's set. So in real life, a constant that you might know is pi. Pi is the ratio between the circumference of a circle and its diameter. So therefore, we can basically we can set other constants in our program based on what we know of a value that won't change. So if you're making like a computer game or something, you might want like the force of gravity to remain constant, so you can't accidentally overwrite it or what have you. That's the main reason why you would use a constant. You will get more marks for using it in your coursework, so you should be aware of them, and you should try to use them where possible. Okay, so that is actually the end of the demonstration for this lesson. That was a nice short lesson, wasn't it? So what we're going to do is we're going to go back to, I've got one exercise. I want you to change the program that we just looked at. Okay, you can rewind so you can go and have a look at that. But change the program so it displays the cost as well as the VAT and then its total cost. So at the moment we're only displaying the VAT, aren't we? I want you to output the cost of the item. I want you to tell me how much VAT we're going to pay on the item. And then I want you to output the total cost. So you're going to have 3 lines as your output, a bit like a little receipt. Okay, so pause the video, have a go, and then you can restart, and then I will go through the solution for you. Okay, welcome back. So I'm going to now go through the solution to this program, and it's kind of easy. You can probably do it in 2 extra lines, but we might add a 3rd one in just to help us out. Okay, so in our program, we want to get output the cost. So the cost is easy. We've got that stored because the user entered that. So tell you what, let's spice the program up a bit. Let's put right line. Let's put a little header in there. Console dot right line summary of goods. There you go. Look at that. Oh God, I can't type. Right, console.writeline. There we go. So summary of goods. So let's output the total cost. Easy stuff. Right line. In fact, let's leave a blank line because it looks nice when you do that. Console.writeline cost. So the cost is going to be set to and cost. Now I can put a little pound sign before those values there, and it just puts them into a bit of context for me there, doesn't it? So I've got cost is set to whatever the cost was. The VAT we've calculated by working out what the tax is. Okay. Now the total cost is going to be the cost plus the VAT. Now I'm going to show you two ways to do it. First way is you can just do it in this line. Console.writeline. The total cost is. Let's put my pound sign in there ready for this, and what I'm going to do is using my brackets again. You don't have to actually use brackets, you can do it without, but it makes it a bit tidier. I can just do cost plus tax, and that should work. So if I run the program, an item which is costing me £10, the VAT is £2, the total cost is £12. Now you might want to, and there is no harm in doing it, you might want to set up a new variable called dim total cost as single, and then we can assign that total cost to it. Okay, now that might be handy if you need to refer to the total cost multiple times throughout the program, and if you do, that will be a lot quicker than you generating that value at runtime every time you need it. Okay. Now, in trivial small programs like this, you're not going to notice any difference. However, if you do want to be writing very efficient programs, you need to be thinking about these things. You can use up a little bit more memory because in the context of your computer's memory, trust me, you're not using too much by doing this, but you will be writing a slightly more efficient program by doing it. So total cost is going to be set to cost plus tax. Okay, we could also work out total cost, in case you don't know, by multiplying that by 1 plus whatever VAT was there. But either way, you're going to arrive at the same answer, but you're now doing it using an extra variable. Okay, so in summary, you've got different data types. Have a look at the table that I've provided earlier on in this video, and you now know how to set up constants. Okay, so hopefully you will join me again for part 4 of this video series. I'll see you in the next video.